If anybody wants it, wants to pay the freight, you can have it. We'll figure that out. This guy is an A.O. Smith that came off of a Stay-Right P2R out of a 1989 Hot Spring Classic. And it runs fine. It's just the front bearings out of it is really noisy and really not a motor anybody would use anymore. It's actually pretty small horsepower. It's only 3/4 of a horsepower. And the P2R is really obsolete. Off camera, I went in and wired up this pump. So I wanted to show you just how bad it sounds. She's sounding pretty rough. So I've got her all wired up here, and a few safety things. I ground everything I'm working on. Don't be in a rush and just hook up your power wires. Hook up the ground, because if there's a serious fault in this motor, you want this ground to take that abuse. You don't want to be anywhere near something that's got a hot chassis. You touch it, stand on concrete, that might be the end of you. Also, while I didn't put a strain relief in it, I did zip tie the cable to the barrel of the motor. That way it can't get accidentally pulled out or something weird happen. Then this is a 115 motor. I'm not just gonna plug it in with a cheater cord. I've actually got it on surge protected power supply that has a relay in it. So we're not hot swapping or powering this motor on by the cord. Gonna go ahead and turn it on now. You can hear just how bad she sounds. She sounds pretty freaking bad. Good look at that. All right, have all my my goodies ready. We'll start tearing this guy down. The first thing we're gonna do is take this starter switch off. And the canopy makes a convenient place to put your tools. Now you've got this little bracket underneath it here that it actually sits on. I can normally do this a lot faster, but I'm trying to do this for your guys' sake. The next thing we got to do is get the centrifugal part of the switch off, and that's this guy here. So we've explained this before in other videos, but when this motor gets up to speed, that flyweight flies up like that and opens up the switch that sends power to this capacitor. Let's get that guy out. The shaft is a double D shape, so we can get up underneath of it and lock it with a 7/16 inch wrench. Although she doesn't want to cooperate today. There we go. Next thing we want to do is just take and pry this right here. There we go. Spring popped off. Get him before we lose him. You got to have the right weight springs for each motor. And unless you have access to the, unless you're some kind of fancy engineer, you got access to their information. You're probably not going to be able to figure out what those are. So it's best not to lose them. I'm trying to pop this flyweight all the way out of here, but it doesn't want to cooperate. They never do. There we go. So there goes the flyweight. And we'll fish that spring out of there. There's the spring. So once we got all that out of the way, we've got the rotor locked with our screwdriver there. We get on here with a screwdriver. Maybe a better screwdriver than this. This is a precision ground screwdriver. So you look at the profile of it, it's not a wedge. It's ground completely flat. It's flat all the way up to here. And for screws like this is really what you want to use. What I was using a second ago is just a standard wedge-shaped screwdriver. Get rid of our flyweight. The governor off of here. Governor, centrifugal switch, whatever you want to call it. Get rid of the wrench. And you can see, once that's removed, that governor rides on a double D-shaped feature here, contour, that keeps it from spinning loose or spinning off. And it's missing a bolt, which tells me it's been rebuilt before. And that's fine, it'll work just fine with 3 bolts in it. I'm sure we're actually gonna find a broken off bolt in the end bell. So next thing we gotta do is make our witness marks. I don't know if you watched my videos before, we always make witness marks on cases and end bells. It just makes it a lot easier to reassemble the motor. And all you gotta do is just make a little gouge. And let's see if we can pop this end bell off, or actually pull the whole rotor out. You never want to hit on the back of the shaft. You can really damage the motor. Okay, so there's our rotor. That's the sweet nectar we're after. Let's take a look at these coils in this 36-year-old motor. They're like brand new. The copper that they used way back then was much better than what they're using today. So we'll set this motor barrel aside and we'll shift our focus to this rotor over here. All right, we've shown this a lot of times before. This is a special pull adapter because you can't get the hooks of the, or the arms of the puller behind that bearing. It's too close to the fan. So we use that, and we have our handy dandy puller, and we're just going to use a small 1/4 inch impact to pull that off. You shouldn't really need anything more than that. There shouldn't be tons of force on pulling this bearing. If there is, you're going to want to probably try a different strategy, warming the bearing up or cutting the bearing off, because you can actually bend these motor shafts pretty easily. This one looks like it might be stainless, and stainless can be a little soft. So here we go. I'm gonna try to get my hand out of the way so you can see that bearing come off. Get it set it up. Yeah, that's how they're supposed to pull. How about that? There's our fending bearing. She's in pretty bad shape. Gonna shut you guys off. I'm gonna go grab a, let's see what we got here. So that's a used bearing. See how easy that's a bad bearing there. See how well that's spinning, easy that's spinning? Should have some preload on. That's a used bearing, but it's good. Sounds good. Since this motor's probably never going back into service, I'm just going to go ahead and put this used bearing in it. And I'll show you how we do that. Pretty easy. We'll clean the shaft up too once we get the motor running again. So you set it on there. This is a special 203 bearing driver. You see the end's all mushroomed up. And I'm gonna get out here a little wider shot where you can see what's going on. Here we go, have our bearing on. And we're going to put the end bell back on. This bearing driver works real well to seat them. Nice and seated. Got to go find a screw for that missing screw, and we're going to put this. We're recording. That kind of sucks. So here's where we're at. I got the motor barrel back up here. I went ahead and put the rotor back in it, and now I'm going to pop this rear end. Doing motor standing up, but I don't have any way to film with it standing up on its end. And we'll do it this way. I've done enough of them. I can do it this way. Now, we got that snug. 7/16 inch opening wrench. And we'll go in behind here. We'll get on that shaft. Now we want to grab a hold of this thing. Make sure that it's not rocking or anything like that. And again, let's go back to our nice precision ground screwdriver. want to just make sure that's tight. It has a washer on the back side of it, which once it smashes flat, that's tight. Don't over tighten it, you'll be sorry. Let me get this in a position where I can work on it easily. Okay. So, next thing we'll do is we'll put the flyweight in. And, son of a biscuit. Yeah, if you weren't watching, this would go right in. I've done hundreds and hundreds of these, but of course I don't work on these types of motors much anymore. You just don't see them. You don't have these type of centrifugal clutches or switches. So you can get in here and just, there we go. All right, she's in. Now, because we spread that out a little bit, one thing I like to do is just take a pair of channel locks. Just give it a little squeeze. Just close that up. Make sure it doesn't bind. Don't close it up too much. Now, there's two ways you can do this. You can poke through your fingers, or you can use some needle nose pliers. And I'm probably just going to let them poke through my fingers. Now, here's what I do in the field. I take a flathead screwdriver and I jam it into the spring back here. Look at that. A tool like it was a tool made to do it. Let's do the other spring. Okay. There we go. All right. Both my springs back on. Look good. Don't look like you're gonna flop off or anything. Now, I'm gonna prop you up a little bit here. And we're gonna learn some important stuff. You gotta be careful tightening it up, because if you go to town on that screw, you will change the gap. I don't know if you saw that move just then. So what you need to do now is act like you're opening that spring, and I think the gap is supposed to be about 45 to 60 thousandths. I could look it up, but I know that I got a gap there. I know that's going to work. We've got a piece of insulating plastic that goes over top of it. Then we've got one hole clamp, almost like a wire clamp, but it's not. It's only like a quarter round instead of being all halfway around. And then we have the special screw here. Not really special, it's like a 1032, but it's like a, cuts its own threads. All right. Quick and dirty. She is got a new front bearing in her. Let's turn her on and see how she sounds. All right, guys, moment we've been waiting for. We're gonna test run this motor and see how she sounds. Oh man. The switch is set right. Ladies and gentlemen, that's a 36-year-old motor off of a Stay Right Dynaglass P2E, or P2R probably. And I put a used front bearing in it. She sounds like brand new, but it's not a motor you could reuse this for a swimming pool, just a C-flange motor, a square flange motor. You could reuse that for a swimming pool motor, something like that. Matter of fact, if anybody wants it, wants to pay the freight, you can have it. And that's it for that motor. Runs like a champ.